Whenever I'm giving lectures, especially to students, the first thing I will tell them that is, effectively, half of everything I say is BS. They just got to figure out which half. And what I mean by that is, in research, of course, we think we understand. At 10, 20, 30 years go by, and we realize somebody's come along and proven whatever we said wrong. In other words, BS. And so if I'm lucky, half of what I say is correct. If I'm unlucky, more than half will be BS. Maybe if I'm a better astronomer, it'll be less BS. Anyways, that's what we're talking about today. The BS in research.
The GERA Foundation presents this series called Navigating Research.
The man beside me was my master's and PhD supervisor, Professor Victor Alvin Hughes. A lot of people didn't like the guy. At Queen's University, they did not see eye to eye, I can assure you. I remember many altercations. I quite liked the guy. He had a great sense of humor. I'm pretty sure he's Northern English. Came to Canada in the early 60s. But anyways, I got along with him. Maybe it's because I'm a little disliked as well, and he and I were sort of common company. Anyways, he was quite a famous radio astronomer in Canada at the time, and when he came actually out of Cambridge or Jodrell Bank, wherever he worked originally. Anyways, he's quite famous for HW sources, Hughes Veltillout sources, and if any of you have studied star formation in the Northern Hemisphere, you will have looked at Cepheus A, where you find lots of these HW sources. Well, they're named after him. He's one of the names, Hughes and Veltillout. Anyways, that's not what I'm talking about. As it relates to this topic of BS, I remember one very clear discussion we were having after a conference. We went to an American Astronomical Conference together, and there was a lot of argument about Cepheus A, and he had proposed there were 14 star-forming regions in it. 14 B-type stars were being born there. And others were arguing, and I won't give names, I just won't give names, but they didn't like Vic Hughes, and they did not see eye to eye. I don't know the real reason, they just didn't see eye to eye. And he had proposed the 14 star-forming regions. They argued there's only one single O-type star responsible for all the radio emission. So there weren't these HW sources, they were just globules of intense radiation from a more diffuse H region. That was, I guess, their proposal. Anyways, this guy was proven correct. Ultimately, James Chibuzi, at least I've seen some of his work in the probably only 10 or 15 years ago, demonstrated that there in fact were more sources, probably more than just James, but I remember him telling me about this, and I was quite pleased for Vic. He's since died, and he didn't know this. Anyways, the thing I take away from Vic Hughes that I always remember is related to that simple fact. He said, if today because we were arguing about it, because I was saying, well, what if? And he says, well, listen, if today my data shows there are 14 star-forming regions, I publish. If tomorrow my observations show that there's only one star-forming region, guess what? I publish. And I remember that, and I thought to myself, that is spot on. That is science. We follow our observations. That's all there is to it. You know, we're not right or wrong. We're just presenting our observations and making what we think is our best guess what we're looking at. That is astronomy. That's what he taught me. He taught me many things, but that was one of the main ones I remember. Let me give you an example of this BS that I'm referring to, using my own work so I'm not embarrassing anybody else. And it's not BS, as I said, what my supervisor said is correct. So this is a paper I wrote in 1993, and it basically confirmed all of the results of other researchers that had been finding at the time, and that is that these strong methanol masers, in this case the 12 gigahertz masers, were relatively non-variable, less than 15 to 20%, as you can see here. Okay, all that sounds cool. That's 1993. Published, happy. In 1996, I publish a new paper that in fact refutes my original paper in 1992 that said this source in particular was quite variable. And this goes against all of the considered beliefs at the time, including my own. So I monitored this source for 3 years, every 3 days, to be able to make the light curves that I don't show them here. I just give you an example. But the upshot of the story is this result refuted my original result from 1993. So I actually proved that I was talking BS in 1993, in 1996. Unfortunately, nobody believed my results from this paper until into, I think it was probably in the year 2005 or something like this. Confirmation of variability in these sources was given by this amazing piece of work by Sharmila Goodhart. In 2003, she discovered periodic methanol masers. That in itself was far more exciting than simple variability. Unfortunately, as is the case, people didn't believe her. They thought it was some kind of instrumental error at Hartrell. How could a small 26-meter telescope in Africa make such an amazing discovery? It seemed that was the attitude of the time. Fortunate for Sharmila, fortunate, 7 years later, they published a result. This group here, Arroyo et al., published the periodic methanol and formaldehyde masers in a source, and that paid to the argument that she was talking BS. She was proven to be right, but it took 7 years, and she wrote other papers and found other sources, if you could imagine. So, people were sitting there saying, well, we don't really believe your results. Obviously they were wrong. And by extension, it proved that my variability paper was also reasonable, though I used it to prove my original BS was BS. Ain't that interesting? Anyways, so there it is, 1993 to 2010, when they started accepting the concept or the idea that these methanol masers were truly variable. And, I was one of the culprits. I was also saying that. So I was proven to be talking BS 20 years before. So, in conclusion, it took 20 years to prove that I was talking BS in 1993. I take full responsibility for what I published. And others, they can decide if they want to call it that or not. I don't care. But the reality is my supervisor was spot on. He said very clearly, if you find data at the time that shows X, Y, Z and you can support it, publish. If you find data the next day, in this case, I found data 3 years later, in 1996, I published. Fortunately for me, Sharmila found periodic methanol masers, which really blew away the idea of non-variability, and then found other ones to confirm that she wasn't talking BS. Okay? But it actually took till 2010 to prove that even she was absolutely right. It took until another telescope could do long-term monitoring to show that other sources were periodic on another telescope. 2011, Marian Zimzak did the same out of Poland, did a great job as well, found some nice periodic methanol masers also. So it took literally 20 years to prove that I was talking BS in 1993. If my students had been around then, they could have called me on it, and 20 years later, they would have been right. I was wrong. That is science. That is what we do. Don't be afraid to publish. Even if you're wrong 20 years later, it's okay. It's all right. As long as you follow, you follow those paths. Be honest. Make sure you give lots of references to all of your discussion points that you're putting in your paper, and ensure that your data is reasonable and well vetted. In other words, double check your analysis of the data, your observing methodologies, all of that. And if you do all those things, the data is publishable. That's all there's to it. It's science. That's what it's all about, especially astronomy. And I go back to my final point. On my BS meter, it's man the lifeboat. So in my case, I say 50-50. 50% of everything I say is BS. Well, maybe it's less than that. Maybe I'm wrong 20% of the time. I certainly embellish, so that'll actually make my BS meter go higher. But the reality is that that's science. That's science. Just go and do your work. Do the best you can. But as I said, if you're honest and you follow good methodologies and you're always giving good references or finding references to your discussion points, it's publishable. It's publishable because you can stand by the data. New data will prove something different. That's for the future. So, go out there and do some good observing. And don't be afraid to be wrong. The real question we should be asking ourselves is why were we so surprised to find out that they were variable? And to be fair to my colleagues and myself for that matter, we did say that we never said they were non-variable. We said they varied at a very small amount, like 10, 15, 20%. So we did recognize that there was variations, but the real question is, why were we so surprised that they were variable? And some of them quite strongly variable, such as the source I published in '96 and the periodic masers that have since been discovered by so many people. And the answer is really quite simple. We based it on, okay, good science. We had observations in previous epochs, but we didn't have a good cadence. So we didn't have observations continuously taken over years, which we now have. We have data sets. I have data sets 30 years old. Others have data sets 10, 20 years old. And those lengthy data sets with systematic observations every 2 weeks or every 5 days or every 1 month, whatever, they give you a much clearer view of the real variations. And that's the answer. So no indictment to any of my colleagues who published articles that said these things weren't very variable, including myself. We did what we thought was good science, but we just didn't have the cadence. We just didn't do the cadence. Today we're doing the cadence. And the Maser Monitoring Organization, the M2O, is doing a great job trying to organize that around the world to all these small observatories so we do better cadences to more sources at more transitions. And that'll do greater science. So, it wasn't BS before, but we did demonstrate that the dogma of the 90s was in fact incorrect. It was based on bad cadence.
The GERA Foundation will produce more videos like this. Please like, share, or subscribe if you enjoyed this video.